Assalamualaikum and good morning everyone. Okay, so for today we are going to discuss about the hydraulic fluids. Okay, uh, so the lesson outcome for this topic, by the end of this lesson you should be able to explain the hydraulic fluid characteristic and general type of hydraulic fluid. Okay, we begin with some history of hydraulic fluid. Okay, water was the first fluid used for transmission of fluid power. Okay, so before the scientists find out the oil and synthetic oil, okay, the water is the one that being used for the power transmission. Then the main advantage of water as hydraulic fluid is the availability, low cost, and fire resistance. Okay, so now we know that the water is freely available, and it's also have the fire resistant features. But in terms of the disadvantages of water, okay, it's corrode. So we know that if the material, especially the metal, is exposed to the water and also air, so it may corrode. Okay, then the water also will evaporate in high temperature, so means that it's not suitable to be used in high temperature condition. It also support growth of bacteria. Okay, it has contamination, then poor lubricity and low viscosity. So that's among the disadvantages of water. So some history of hydraulic fluid. Okay, mineral oil are readily available at beginning of 20th century, but were not practically used in hydraulic system. Right, so the mineral oil was found in early of 19th century. Then the first additive were used to improve the physical and chemical properties of hydraulic mineral oil. Okay, so the additive was then identified to improve the physical and chemical properties of mineral oil. Then the first additive were developed to counter rust and oxidation. So as we know previously, the only available fluid is water. So the main problem with the water is the rust, corrosion and oxidation. Okay, so the scientists try to improve the properties of the fluid by adding the additive into the water. Some history about the hydraulic fluid, but mineral oil are highly flammable and fire risk increases when operating at high temperature. So we know that the mineral oil, okay, that basically from the petroleum base are highly flammable. Then it has a fire risk increased when operating at high temperature. So means that this kind of mineral oil is not suitable for highly temperature condition. For example, if we want to use in the process like injection molding, then if we want to use at the furnace and so on, so this kind of fluid is not suitable. This has led to the development of free resistant fluid that are mainly water-based with limitation on operating condition. Okay, so the scientists were developing the water-based fluid, okay, but it has the limitation in the operating condition. So in order to avoid the fire hazard, okay, they use the water-based, but when they use water-based, it has some limitation. Okay, the need for extreme of operating temperatures and pressure led to the development of synthetic fluid. Okay, then the primary function of hydraulic fluid is for the power transmission, so to transfer the power, as a lubrication, okay, to lubricate the movement of the component inside the hydraulic system, okay, for the sealing, so means that the fluid itself, okay, become the sealing agent for the component. Okay, thin hydraulic film act as sealing that reduce leakage. Then cooling, capable to absorb heat generated by a moving part. Then cushioning of oscillation caused by pressure jerk. Okay, so The hydraulic fluid here is also work as the pressure, the jerking absorption. Okay, so currently we know that we have the suspension system that use the hydraulic system. So the hydraulic fluid inside the suspension work to absorb the jerk. All right, then it also being the corrosion protection. The hydraulic fluid should be able to protect the component from the corrosion. Okay, these are some of the fluid characteristics that we need to consider. Okay, viscosity, oil density, oil compressibility, okay, vapor pressure, lubrication, anti-wear characteristic, compatibility, chemical stability, oxidation, and environmentally acceptable hydraulic oil. Okay, so we try to discuss one by one the characteristics here. Okay, we begin with viscosity. Okay, describe the resistance to the lamina movement of two neighboring fluid layers against each other. So I believe that for the viscosity, basically you already learned in fluid mechanics. Okay, in simple word, viscosity is a resistance to flow. It results from cohesion and interaction between molecules. So means that normally the higher viscosity of the fluid is, it become more resistance and make the fluid is difficult to move, right? Okay, important to keep the oil viscosity within a certain range. Okay, basically the viscosity is one of the parameters, the important parameters in hydraulic fluid that determine the characteristic of the fluid itself. Okay, the viscosity index of oil is a number used in industry to indicate effect of temperature variation on the viscosity of the oil. Okay, so there is one indicator that normally being used in industry, which is VI or viscosity index. Okay, a low VI signify relatively large changes of viscosity with temperature variation, right? So when the fluid is having low VI, okay, so means that for this fluid, when the temperature is changed, okay, the viscosity will also have a large changes, okay, in the temperature changes, right? Then a high VI means relatively little change in viscosity over a wide temperature range. Okay, the fluid with high VI is having little changes in the viscosity, even though the temperature change is wide. Okay, so which one is the best? So the best oil is the one that maintain constant velocity throughout the temperature changes. Okay, although it operates at the room temperature, okay, compare with maybe 45 or 50 degrees Celsius, the viscosity can be maintained. That is the best one. But of course, the higher viscosity index fluid is much more expensive compared with low VI fluid. So this is the effect of viscosity on hydraulic system operation. Okay, the oil viscosity influences the function of hydraulic power system as it introduces resistance to fluid flow and to the motion of moving bodies in the fluid. Okay, so for high viscosity fluid, of course, it is having a larger resistance compared with a low viscosity fluid. Okay, for example, if we just compare the oil or the water with grease, for example. Okay, so of course the water is having a lower viscosity compared to grease, and the water is more easier to be transported compared with the grease, because the grease is having high resistance compared with the water. Okay, so the following effects are studied. So the effect on the hydraulic system, hydraulic losses in transmission line. So when we use high viscosity fluid, okay, the losses in transmission line is high compared with when we use low viscosity fluid. Okay, then resistance to fluid flow in narrow conduct. Okay, so another effect is if we use high viscosity fluid in a tube, okay, it's much more difficult to move from point A to point B, okay, because of high resistance, okay, compare with the fluid with low viscosity. Okay, so there is another effect. Then the third one is viscous friction forces and damping effect. So it will affect the friction and also the damping on the system. Alright, so next one is oil density. Okay, density is rho equal to m divided with V, okay, mass per volume. Okay, the hydraulic oils are of low compressibility and volumetric thermal expansion. Right, so the hydraulic oil is the one with low compressibility and volumetric. Therefore, under ordinary operating condition, the oil density is practically constant. So means that in this study, we assume that the oil density is constant. Right, the density of mineral oil range from 850 to 900 kg per meter cubic. Okay, so as you know, the water is having a higher density compared with the oil, which is 1000 kg per meter cubic. Okay, the oil density affects both the transient and steady state operation of the hydraulic system. So this is one of the effect of oil density in the hydraulic system. Okay, it will affect the transient and also steady state operation. Then it also affects the local losses, okay, result from rapid variation in the magnitude or direction of the velocity vector. Okay, for example, throttling element, elbows, and connection area. So throttling element means we have one valve that control the flow, right? So when we have the valve, okay, so it will have the resistance, so that there will be a losses. Okay, the fluid with higher density will have the higher losses, then directly proportional to the fluid density, so the local losses here. Then the second one is hydraulic inertia. Okay, if occur during the early running state, okay, affect the transient response of hydraulic transmission line, but has no significant effect on steady state behavior. Okay, this one is occur during the early. For example, we use a simple aquarium pump, for example. Okay, we put the pump inside our aquarium, turn it on. So for the first few seconds, if we see the flow, okay, the flow is not stable. Okay, because there is a density effect, okay, on the operation. But after a while, maybe 5 to 10 seconds, so we can see the laminar flow come out from the channel. Okay, so it means that during the early state, okay, the overall system is not stable yet, because most of the piping or tubing in the hydraulic system is not being filled with the fluid yet. Okay, once the fluid already running and fill every single volume in the channel, so normally it will have no effect on the hydraulic system. Okay, next is about the oil compressibility. Okay, it's defined as ability of liquid to change its volume when its pressure varies. Okay, liquid are of very low compressibility compared with gas. Therefore, liquid are usually assumed incompressible. Alright, so we already learned this one. Okay, maybe from your secondary school, we know that the liquid is incompressible compared with the gas. So we know gas can be compressed, but in reality, okay, generally the reduction of oil volume by 1% require an increase of its pressure. Okay, in reality, if there is a pressure increment, okay, the volume also will be reduced. Okay, in for liquid, when we have the pressure increase by 10 to 20 megapascal, so 1% of the volume will be reduced. That is the in real condition. Then lubrication and anti-wear characteristic. The fluid must be capable of covering the contact surface of all moving parts with a thin and continuous lubricating film. Okay, so basically it must be capable to cover, okay, moving parts. The lubricating film may be destroyed as a result of high loading forces, insufficient of oil delivery, and low viscosity. So as we know, one of the function of hydraulic fluid is for lubrication. Okay, but this film might be destroyed. Okay, if we use the system with excessive high pressure. Okay, lubricating power and film strength of a liquid are directly related to its chemical nature and can be improved by addition of certain chemical agent. Then in terms of compatibility, fluid must be fully compatible with other material. Okay. It should not react chemically with any of these material or change their physical properties. Okay, so this is one of the condition that we want to avoid. Okay, moreover, the fluid leak out from the hydraulic system and encounter other system part. Okay, when there is a leakage happen, okay, if the fluid is not compatible with the component, it also might attack the other component. Okay, as such as electrical line, okay, mechanical component and others. Then in terms of stability, the hydraulic fluid must be stable in terms of chemical and oxidation. Okay, some metals such as zinc, lead, brass, and copper have undesirable chemical reaction with certain liquid. Okay, the fluid stability is important to ensure that there is no chemical reaction occurred in our system. Then environmentally acceptable hydraulic fluid. Okay, an oil leak may result in considerable pollution of the surrounding and groundwater. Mineral oil are compressed of relatively stable hydrocarbon compound and are only very slowly broken down by microorganisms. Okay, so we know that the oil that we use must be compatible with environment. And when we want to dispose the oil also, we must follow the regulation set by Department of Environment, right? So you must check how to dispose the fluid, okay? Then the most common problem occurred when the system is leaking. So the company is not purposely want to dispose or want to let the fluid goes to the environment, but the oil leaking is occurred. So that's one of the condition that we want to avoid. Okay, next we move to the classification of hydraulic fluid. Okay, we can classify hydraulic fluid into a few classification. The first one is mineral oil. Okay, this is the most widely used hydraulic fluid. Okay, relatively inexpensive, widely available, and can be offered in suitable viscosity grade. Okay, good lubricity, non-corrosive, and compatible with most sealing material, with exception of butyl rubber. Okay, chemically stable for reasonable operating temperatures at high temperature. However, they suffer chemical breakdown. Okay, so for the mineral oil, basically this kind of fluid can be used in most of the places, but we need to be aware when we are using the butyl rubber material inside our hydraulic system. Okay, because it can react to this material. Okay, premium grade mineral oil contain a package of additive to combat the effect of wear, oxidation, and improve viscosity index and lubricity. Okay, so some advantages of mineral oil cannot be remedially by incorporating additive. Okay, so mineral oil is also high flammability, then increase in viscosity at high pressure. Okay, previously for viscosity index, we are talking about viscosity changes with the temperature, but in this case, viscosity is changes with the pressure. Okay, fire risk exclude the use of mineral oil in hazardous areas such as injection and plastic molding. coal mines and near furnace. So means that this kind of fluid mineral oil is not suitable for high temperature environment. Okay, the viscosity pressure characteristic limit their use to pressure below 1000 bar. Okay, so we need to limit the usage of mineral oil below 1000 bar. So 1000 bar is basically is already high pressure. Then the second type is oil in water emulsion. Okay, this hydraulic fluid consists of tiny droplets of oil dispersed in continuous water phase. Okay, the dilution is normally between 2% and 5% oil in water, and the characteristic of fluid are more similar to water than oil. It is extremely fire resistant, highly incompressible, and good cooling properties. Okay, but it has poor lubricity and low viscosity. Okay, so this is the oil in water emulsion. Okay, means that the base material here is the water, and as we know that for the water, it is a fire resistant, then but it has a problem with the evaporation and so on. Okay, so there are small percentage of oil is inserted into the water-based fluid. Okay, just 2 to 5% only. Okay, so they can increase a few characteristics. Okay, then the next one is water in oil emulsion. Okay, most popular fire resistant fluid. Okay, they have continuous oil phase in which tiny droplets of water are dispersed. Okay, their lubrication properties are very much reduced. Then for optimum life, the operating temperature should not exceed 25 degrees C, but intermittent operation up to 50 degrees C is permissible. Okay, so for water in oil, the base material or the base fluid is the oil. Then tiny droplet of water is inserted into this oil. It's not the normal water as we use, but the water that has gone to be chemically processed. Okay, but the temperature, if you look at the operating temperature there, is relatively low. Okay, just below 50 degrees Celsius. Then at the high temperature, the water content is affected owing to the evaporation, which decrease the emulsion of fire resistant properties. Okay, so for this type, the water content at the high temperature, the water content will be evaporated, and it will affect the performance of the system. Okay, when the system has been idle for a long period, there is a tendency for oil and water to separate. Okay, however, during running the pump, we will re-emulsify the fluid. Okay, if we left the system or the fluid for a long time, okay, the water and the oil will be separated. Okay, so that it's not being emulsified. So when we want to start the system, it's a good practice basically to mix the fluid back. Okay, next is water glycol fluid. Okay, was developed primarily used in aircraft because of low flammability characteristics. Okay, water glycol fluid. Application is limited since they cannot be used at high temperature because of their water content. Okay, lubricating ability is inferior to the mineral oil. They attack atmosphere. They are very stable with respect to shear because of low molecular weight of their constituent. Then good antifreeze properties make them particularly suitable for low temperature application. Okay, so remember for water glycol, okay, purposely used in aircraft and suitable for low temperature application. Then next one is synthetic oil. Okay, the example here is phosphate ester. It has good fire resistant properties. Okay, used in industries such as molding and die casting, where usually great fire risks occur. Okay, this one is the option or one of the more mainly used in the industry with high temperature. Okay, then their lubricity ability is similar to that of mineral oil. Okay, if you remember the mineral oil, it has high flammable risk, but the synthetic oil, it still has a good lubricity ability, but at the same time, it also has a good fire resistant properties. Okay. Okay, synthetic oil are superior when compared with mineral oil. Okay, I already explained this one. Then, in terms of viscosity temperature properties or VI index, it's also is better than mineral oil. But in terms of disadvantages, elastomer used in conjunction with phosphate ester must be chosen carefully. So there is one chemical that need to be inserted into the oil. Okay, this elastomer need to be carefully used. Okay, certain metal like aluminium and most paint are susceptible to attack. Okay, so for this kind of oil, okay, the chosen of application where we want to use is need to be made carefully, because it will react to some material. The requirement imposed on the hydraulic fluid. So means that we already discussed a few types of hydraulic fluid. So now how to choose the best hydraulic fluid for our purpose. Okay, the main requirement here is satisfactory low properties throughout the entire range of operating temperature. Okay, flow properties throughout the entire range of operating temperature. We want to make sure that the flow properties is constant. Okay, although we are operating in the different temperature range. High viscosity index ensure moderate viscosity variation in relation to the temperature fluctuation. Okay, this one has been discussed earlier. Good lubricating properties, prerequisite to reduce the wear and increase service life of the system. Then low vapor pressure to avoid cavitation. Compatibility with system material, since the fluid should not react chemically with any of the used material or deteriorate their physical properties. Chemical stability necessary to increase the service life. Corrosion protection, okay, by adding effective corrosion inhibitor. So in order to improve the corrosion properties, we can add an anti-corrosion inhibitor. Okay. Rapid deaeration of air separation. Okay, this is one of the features that we want to remove the air inside the fluid. Okay, because if there is a trapped bubble inside the fluid, there are a lot of problems can occur. Okay, good thermal conductivity is required to rapidly dissipate the heat generation due to friction between elements and due to hydraulic losses. Fire resistance is essential in some applications. Electrically insulating properties can be significant in the number of modern design. Then environmental acceptability. Okay, so throughout this lesson, basically we already discussed a few fluid characteristics. Okay, means that when you want to choose a suitable fluid for your application, you must look at these characteristics and the type of hydraulic fluid. So there are a few types of hydraulic fluid. Again, you need to carefully choose to suit with your application. Okay, that's all for this lesson. Okay, thank you very much.